Okay, let's unpack this. Imagine you're managing, say, a bustling university campus, maybe a sprawling hospital network, or even a chain of sports bars. You've got hundreds, maybe thousands, a TV's already installed, right? All wired up with a good old coaxial cable. Now, here's the challenge. You need to get one specific high-definition video source, could be anything, a live campus announcement, critical patient info, maybe that must-watch championship game. You need to get that onto all those TVs simultaneously on its own channel. And critically, you need to do it without spending a fortune, ripping out walls, running new expensive cables.
Sounds like a huge headache, right? Well, today we're diving deep into a piece of technology that precisely solves that exact problem. It's surprisingly common, actually. We're talking about the Thor Broadcast H-HDMI-RF-PETIT. It's an HDMI-RF modulator. Our mission today: explore what this little box does, why it's proving to be such a game changer for large-scale content distribution, and how it basically transforms any standard HDMI signal into what is effectively its very own broadcast quality TV channel. Seriously, think about it.
Taking the output from a simple ROKU stick, or maybe a pro camera, and turning it into, say, channel 37 on every single TV across an entire building. Crystal clear.
What's truly fascinating here, I think, isn't just that it bridges HDMI to RF, but how elegantly it pulls it off. The real aha moment, is realizing this isn't just some simple converter box. It's more like a stealth infrastructure upgrade. It takes your existing coax network, which, let's face it, most people probably see as old tech, and it just effortlessly transforms it into this high-capacity, super reliable pipeline for digital content. This completely bypasses the astronomical costs, the huge disruption, the sheer logistical nightmare of trying to recable an entire building or multiple buildings with new HDMI or fiber. In essence, it kind of democratizes premium video distribution, makes it accessible, affordable for places that traditionally couldn't even think about this level of broadcasting.
That's a really powerful way to put it, democratizing distribution.
Okay.
So let's start with the basics then. What exactly is an HDMI RF modulator? And what specific magic does this Thor HDMI-RF-PETIT perform?
Right. So at its core, it's a device that grabs an HDMI signal. Could be from, your satellite receiver, a proper HDMI camera, a DVD player, your computer, even a streaming stick like ROKU, anything with HDMI out, pretty much. And it converts that digital signal into a standard RF television channel, radio frequency, the same kind your TV tuner already understands.
So you're literally creating your own private high-def TV channel from any of those sources.
Exactly, all contained within this one pretty compact box. It's like having a miniature professional broadcast station right there. Fits in your hand, almost.
Wow.
And if we connect this to the bigger picture, the why behind this becomes super critical. This isn't just some niche gadget for enthusiasts. This kind of solution is vital for those environments we were just talking about. Think about that university campus again. It needs to broadcast maybe emergency alerts or daily campus news, maybe live lectures to every dorm room, every common area.
Right.
Or hospitals, yeah. Patient education videos, important announcements they need to be available in every single room without requiring staff to manually hook up a DVD player to each TV.
Oh, definitely not practical.
Churches distributing services, big apartment complexes offering local info channels, or those sports bars needing the same game on dozens of screens without needing dozens of cable boxes.
Yeah.
This makes it all possible. It's all about leveraging that existing infrastructure, those coax cables already hidden in the walls for modern high-def content, turns them into a really versatile, robust content network. The sources we looked at, they really emphasize this. They call it the ultimate all-in-one solution because it truly packs so many functions into one little device, functions that traditionally would have needed several pieces of gear.
That integration point is key. But okay, when we talk about converting HDMI to RF, I think a lot of people might instinctively worry about the quality. Are we talking just a functional signal, or does this thing actually deliver a professional-grade output that really holds up?
That's a fair question.
And this is where it gets really interesting from what I read. This unit uses HD MPEG-2 video encoding and AC3 Dolby audio. Now, for anyone listening thinking, okay, what does that actually mean for me? Let's translate that.
It means you're getting genuinely crisp, clear, broadcast quality video and rich, immersive sound. That's the goal. It's engineered to make sure your content looks and sounds as good as it possibly can when it hits all those screens down the line. No major compromises there.
Okay, good.
Yeah, and when you actually dig into the specs, it's clear they weren't cutting corners on that professional output. For video, it supports full HD resolutions. 720p, 1080i, and a 1080p. So your content's going to look sharp, vibrant, whether it's live or pre-recorded. You can take it a pretty wide range of input resolutions too, like 720p at 60 frames per second, right up to 1080p at 60, and then it outputs a maximum of 1080p at 30 frames per second, which is totally fine. Perfectly suitable for broadcast TV standards.
And the flexibility seems pretty remarkable, too. You mentioned you have control over the video bit rate, which is basically how much data gets used for the video signal, right? And it's adjustable from 1 up to 19.5 megabits per second, or I think the specs also say 2,000 to 24,000 kilobits per second. Same range, different units. So what's the practical benefit? Why would you want to adjust that?
That's a really crucial point. It's all about balancing quality versus efficiency. It gives you control.
Yep.
If you want the absolute highest pristine quality possible for, say, one really critical channel, you crank that bit rate up, max it out. But if you need to squeeze more channels onto your existing coax network without, overloading it, you can dial that bit rate back a bit for each channel. It gives you that granular control to optimize your setup, either for maximum quality on fewer channels or maybe slightly less quality but maximum channel count. Super versatile for different situations.
Right, like choosing between a huge uncompressed image file or a smaller JPEG online. You pick what fits.
Precisely. You pick what suits your network's capacity and your quality needs.
Makes perfect sense. Okay, and on the audio side, it's not just AC3 Dolby, right? It also supports MPEG-1 Layer 2 and MPEG-2 AAC with a 48 kilohertz sample rate. Various bit rates there, too. Why the multiple audio formats?
Yeah, the multi-format support is really about ensuring broad compatibility and professional sound across the board. AC3 Dolby, for instance, that's a standard for surround sound, high-quality audio, so you get that more cinematic feel if your source provides it. MPEG-1 Layer 2 and MPEG-2 AAC are also really robust audio codecs, widely used in digital broadcasting. Having these options means the device can just seamlessly integrate with a wider range of existing audio systems, different TV models, playback devices. It helps ensure your audio is consistently clear, properly synced with the video, no matter what TV it ends up on.
Okay, uncompromised experience, basically.
That's the aim. Deliver an uncompromised audio-visual experience.
So we've got top-notch video and audio quality covered, but what about compatibility beyond just the content? You mentioned different broadcast standards earlier. That sounded important.
Oh, definitely. The significance of its output formats is actually quite profound. Yeah. The fact that it works with DVB-C, DVD, ATSC, or ISDB-T formats, that's a huge deal. These aren't just, random letters. They're the major digital TV broadcasting standards used all over the world. ATSC, for example, that's the main one in North America. DVB-T is big in Europe, Australia, parts of Asia. DVB-C is for cable systems everywhere, and ISDB-T covers Japan and most of South America. So what this means is the device isn't just locked to one region. It's incredibly compatible with broadcast systems pretty much anywhere on the planet.
Wow. Okay, hold on. So that raises a real-world question. If I'm, say, a university with international campuses or maybe a global hotel chain, does this mean my standard training video output from HDMI here could theoretically be broadcast easily in a dorm in Dallas and a hotel room in Berlin and maybe an office in Tokyo using the same kind of box, just configured differently?
That's essentially the idea. You need to select the correct standard for the specific region you're broadcasting into, of course. You can't just plug and play across continents without setting it up. But the beauty lies in the device having that capability built into one unified platform. And the user interface, the GUI we'll talk about later, it's designed to make selecting ATSC or DVB-T or whatever as straightforward as possible. It kind of abstracts away a lot of the deep technical complexity that, old school broadcast engineers had to deal with.
Okay.
So for the user, it's less about needing specialized engineering knowledge for each standard and more about making the right choice in a relatively simple menu. That's a massive shift. It makes it accessible to maybe an IT manager in that Berlin hotel who isn't a broadcast pro, or a facilities manager who just needs to get the CEO's message out globally. It helps universalize your content for a global TV audience, assuming they're using one of those major digital standards.
That adaptability is really impressive. It really sets it apart. But, okay, whether it's global content or just our campus-wide feed, getting it to hundreds, maybe thousands of screens, that needs some serious power behind it, doesn't it? This isn't just splitting a signal for 2 TVs in your living room. How much muscle does this little box actually pack?
Yeah, you've hit on a really crucial aspect, scale. This device is absolutely built for reach, serious reach. The RF output power is rated at a pretty robust plus 24 dBmV. Now, to translate that techno jargon into something more tangible, think of it like a really strong, clean signal being pushed down that coax pipe.
Okay.
That level of power, that plus 24 dBmV, is more than enough to reliably distribute your high-definition video signal to hundreds of televisions over a standard existing coax cable network. We're talking a substantial number of screens, all getting that same channel clearly and stably from one modulator.
Hundreds of TVs from one little box is impressive. But what if you've got a truly massive facility? Or maybe you want to offer more than just one channel. Is there a limit?
Not really a hard limit in that sense. That's where the scalability really shines. If your needs grow, or if you decide you want to offer, say, 5 different channels, maybe one for announcements, one for sports, one for movies, whatever, you can actually install multiple of these H-HDMI-RF-PETIT units onto your existing TV system, side by side. Each modulator creates its own unique channel. You just set each one to a different channel number. So you can easily expand your channel lineup and your reach just by adding more modulators as you need them. They integrate pretty seamlessly into a multi-channel setup. You're essentially building your own private mini cable TV headend.
And that ability to use the existing coax cables, that's where the massive economic benefit kicks in, right? Let's really emphasize this for people listening. How big are the savings compared to the alternatives?
Oh, the cost savings they can be monumental. Seriously, just imagine the alternative for that university campus we keep mentioning, running brand new, dedicated HDMI cables from some central control room to every single lecture hall, every dorm room, every common area TV. That's thousands of feet of expensive cable, plus installation labor.
Nightmare.
Or maybe even more expensive, implementing some complex, specialized IP-based video distribution system that needs new network switches, encoders for every source, decoders at every PV, maybe even fiber optic runs. That's not just a project, it's a massive infrastructure overhaul. The labor, the materials, the disruption across the whole campus, it's huge.
Easily hundreds of thousands, maybe more.
Could be millions. And a large enough deployment, absolutely. So when you look at the price of this Thor modulator, currently $469, which is already great value, down from an MSRP of $562.80.
And didn't you mention a discount code?
Yeah, they mentioned a 5% discount code, 5% off. So that brings it down even further. But that affordable price becomes an incredible value proposition when you factor in all those avoided costs. You're completely sidestepping that massive infrastructure overhaul. That's incredibly powerful from a budget perspective.
Absolutely. Okay, so it's powerful, it's cost-effective, but is it easy to use? Nobody wants complicated tech, right?
Yeah.
Especially if you're managing a system broadcasting to hundreds of screens. So how user-friendly is this thing? Is it truly plug-and-play simple, or do you need like a broadcast engineering degree to get it running?
That's always the critical question for wider adoption, isn't it? The sources we reviewed really highlight that it's engineered for plug-and-play simplicity. That's their term, which is a pretty bold claim for something this capable. The control aspect is described as effortless, and that's mainly done through Thor Broadcast's own proprietary graphical user interface, the GUI. This GUI gets praised in the materials as being one of the most intuitive interfaces in the industry, which strongly suggests they focused on user experience, trying to avoid overly complex menus.
Okay, so we're talking point and click, hopefully not digging through command lines.
Pretty much, yeah.
Yeah.
For the basics, at least.
That's good to hear. But surely for a device with this much power and flexibility, there must be deeper controls available for people who actually need them or want them.
Well, absolutely. It smartly balances that simplicity with depth. For your initial setup, your basic operations, setting the channel, naming it the GUI, is designed to be very intuitive, walk you through it. But for those who need that more fine-grained control, it includes a standard 10100 Ethernet NMS port, network management system. This port lets you connect it to your network and then manage everything, comprehensive setup, monitoring ongoing control, all remotely through your computer using that same GUI over the network. You can even tweak things like the RF output power level or fine-tune that video bitrate we talked about, all remotely.
Ah, very handy.
Yeah, so management is primarily via Ethernet and firmware upgrades, keeping the device up to date. That can be done easily via USB or over that same Ethernet connection. Keeps it current.
Okay, so that sounds like the best of both worlds then. Easy entry for maybe the facility manager, but deep customization for the IT or broadcast pro.
Exactly.
And what about those configuration options themselves? Are they laid out logically? Can you get to what you need?
It seems so. The menu structure offers both basic and advanced sections. For most users, you've got straightforward settings. The RF channel range you want to use, maybe a key ID. You give your channel a service name so people know what it is, like campus announcements or lobby TV. And RF attenuation to adjust the signal strength if needed. Simple stuff.
No.
But then, for the broadcast professionals or folks integrating this into more complex systems, you can dive into advanced settings. Things like service provider name, network ID, ONID, TSID, service ID, and then a whole bunch of PIDs. PMT, PID, VPID, AP, PCR, PID, plus network settings.
Whoa, okay. PID, packet identifier, sounds technical.
Yeah, very technical. These PIDs are highly specific parameters for managing the different data streams within a digital television signal. The video, the audio, timing information. We don't need to get into the weeds on each one, but their inclusion shows you have that really granular control necessary to make this modulator play nice in complex multi-channel broadcast environments or meet very specific industry standards if you have to.
That is incredibly powerful, and it really hammers home your earlier point about democratizing advanced video distribution. When the tech is intuitive enough for basic use, but also has that depth, it just lowers the barrier to entry so much. Think about a small church, maybe a community center, even a local business wanting its own in-house ad channel, places that definitely don't have dedicated broadcast staff.
Precise.
This opens up possibilities that, yeah, were probably once just for the big media players.
It fundamentally changes who can participate in distributing high-quality video content effectively.
Yeah.
That accessible control is key.
And it's not just powerful and flexible on the inside, right? It's practical on the outside, too. The descriptions mention small size and lightweight, and it even comes with wall mount type rack ears.
Yeah, little things that matter in the real world.
Makes it super easy to just tuck away, integrate into an existing equipment rack, or mount on a wall without taking up precious space. Plus, another big practical benefit, the HDMI input is HDCP compliant, which basically means it works with any HDMI device, right? Removes those annoying compatibility headaches with protected content from, say, a Blu-ray player or a cable box.
Huge plus. HDCP compliance is essential these days.
And the cherry on top, it supports any CATV RF Agile channels from 57 all the way up to 1,000 megahertz. That covers channels 2 through 135.
Wow, that's broad.
An incredible flexibility for finding an open channel. It can essentially slot into almost any existing cable system without causing interference.
Okay, so when you stack all of that together,
Yeah.
the really exceptional broadcast quality video and audio, the broad compatibility with global standards, the powerful output that can genuinely reach hundreds of TVs, the huge economic win from using existing coax,
Yeah.
and then layer on that intuitive, user-friendly control that scales from simple setup to deep customization. You really see the complete value proposition here. It clicks.
Yeah.
You're not just buying a little box, a gadget. You're acquiring a comprehensive solution for doing scalable, high-quality content delivery. And at a price point that, especially when you factor in those massive cost savings on installation, is remarkably affordable. And we saw those examples in the source materials, right? People using it successfully for budget church video distribution, someone building their own private head-end for maybe an apartment complex, or folks connecting multiple HDMI-RF modulators for a multi-channel cable TV setup. It really shows how adaptable it is to all sorts of different needs.
So, okay. Wrapping this up, what does this all mean for you, our listener? We've taken a deep dive into the Thor Broadcast H-HDMI-RF-PETIT modulator. It's a device that makes broadcasting your HDMI content, whatever it might be, to potentially thousands of TVs over cables you likely already have. It makes that whole process incredibly simple and effective. What it means is that powerful, professional-grade video distribution. It isn't just for the giant networks or massive corporations anymore. It's genuinely within reach for so many more organizations, applications, from the small local business right up to the large institution. It really transforms how we can think about sharing information and entertainment visually.
And that, I think, leads us to a really interesting final thought to leave people with. Beyond the obvious commercial and institutional uses we've discussed, schools, hospitals, hotels, sports arenas, all that, how might a device like this, something this accessible and powerful, actually empower, say, local communities, small businesses, even individual content creators or hobbyists, empower them to create and distribute their own broadcast-style content within their sphere? Imagine the possibilities. Truly hyper-local information channels, community-focused entertainment, specialized educational programming for a specific building or campus, maybe internal corporate TV networks done easily, all distributed through that ubiquitous familiar medium, the TV, that pretty much everyone already has. So it really raises an important question for the future. What untapped potential lies dormant in making robust, high-quality content distribution this accessible to many more people? What new forms of media, what new kinds of communication might actually emerge when the tools become this easy to use?
Definitely something to ponder long after this deep dive ends. Thanks for exploring this fascinating piece of tech